take a look at a formal proof of what the professor has given an intuition for. I'm going to prove it using the tool induction. So my statement goes like this. If there exists a UV walk, that is a walk starting from U and ending at V in G, then there exists a UV path in G. This is the statement. Now, what are we going to induct on? We are going to induct on the length of the walk. So what will be the basic step? Basic step will be length as 1, that is, the length of the walk is 1 unit. What does it mean? If length is 1, it means that there is one edge, only one edge in the walk. So it goes like this. So he's starting from U, one edge, V. Now this is a path. This is a walk and as well a path. This is the basic step, and hence basic step we see that it is true. Going to the induction hypothesis, what does it mean? I assume that the statement holds true if the length of the walk is less than or equal to K. So if there exists a UV walk in G, there exists a UV path in G of length L less than or equal to K. I'm assuming this to be true. Now, what do we have to prove? We have to prove that if you assume that there exists a path of length less than or equal to K, then the theorem holds true for length K plus 1. So for a walk of length K plus 1, there exists a UV path in G. So assuming that W of UV is a walk of length K plus 1, if there is no vertex which is getting repeated, then we are done. It's a path by definition. Now, let us assume that a vertex gets repeated. What are we going to do? We can write it as, let the walk WUV be U starting from U, edge E1, another vertex say A, edge E2, so on. I'm going to go to the edge say EI, then X. X is the vertex. Now this vertex is going to repeat, that is what we have assumed. After X, there is some edge, so on. Then again you encounter X, then a word edge, say EJ, so on up to the last vertex. Where do you reach? V. So this is the walk. Take a moment to observe the walk. Now, what am I going to do is I'm going to chop off all the vertices and edges like this. So what am I going to do? There are a few edges, at least one, in between the two X. So I'm going to remove those vertices, edges and this repeated X. So what am I going to get? If W dash is a walk from UV, I'm going to write it as U, E1, say A, E2, so on, EI, X, EJ, so on up to V. Did you see that this chopped off part is not there now? And we have reached EJ here. What do we see? We see that this is a walk of length less than or equal to K. Because I have removed at least one edge, so it is a walk of length less than or equal to K. Take a moment to observe the transition from the previous step to this step. Now, what can we conclude from the induction hypothesis? We can conclude that there exists a UV path because this is a walk of length less than or equal to K, hence there must exist a path. So we have proved that if there is a walk in the graph, then there is a path in the graph.